Hello and welcome to part 3 of 6 presentations in mechanical systems for the grade 8 Alberta science curriculum. We're going to talk now about linkages and transmissions. The linkage is the part of the system that transfers your energy from the pedals to the back wheel. In the bicycle, the chain is the linkage. So here you have the gears, 1 gear and 2 gear, and your chain is transferring force. In a car, the fan belt is the linkage from the engine to the cooling fan to prevent the engine from overheating. Chains or belts form a direct link between two wheels, one that drives the motion and the other will follow in the same direction. Machines that are more complex than a bicycle move much larger loads. A special type of linkage is needed. This is called a transmission. You'll find that in cars. So this is the transmission of a car. It transfers energy from the engine to the wheels. A transmission contains a number of different gears. This enables the operator to move the object slowly with a large force or quickly with a smaller force. Gears are essential components of most mechanical systems. They consist of a pair of wheels that have teeth that interlink. When they rotate together, one gear wheel transfers turning motion and force to the other. Gears transfer energy in a mechanical system. Gear wheels, which are wheels with precisely manufactured identical teeth around its edge, work together in gear trains of 2 or more wheels, transferring rotary motion and force from one part of a complex machine to another. Here's an example, an old-fashioned egg beater, as well as a group of 3 gears. Gears can be used to change the direction of motion in a mechanical device, such as in an egg beater. So you have rotational movement in one direction. This rotates in this direction, and the egg beaters rotate in this direction. Gears can also be used to increase or decrease speed or force. The small gear here, Y, is called a pinion. The gear that supplies the energy is called the driving gear. That's X. The gear to which the force is directed is called the driven gear, which is Y. The large gear X driving a smaller gear Y decreases the torque and increases the speed of the driven gear. So torque is sort of like power. Gears such as these are called multiplying gears. Here, a large wheel or a large gear driving a smaller gear is a multiplying gear. A small gear, Y, driving a larger gear, X, increases the torque and reduces the speed of the driven gear. Gears like this are called reducing gears. When the driving gear has fewer teeth than the driven gear, the driving gear then rotates more slowly than the driving gear. A car or bicycle in low gear uses reducing gears. When the driving and driven gears are the same size, they are known as parallel gears. So there you have an example of a parallel gear. Machines help people do things that they normally couldn't do on their own. Mechanical advantage. A machine makes work easier for you by increasing the amount of force that you exert on an object. This produces mechanical advantage, which is the amount of force that is multiplied by the machine. The force applied to the machine by you is the input force. The force that is applied to the object by the machine is the output force. Calculating mechanical advantage. The mechanical advantage of a machine is the output force divided by the input force. So mechanical advantage is equal to output force divided by input force. There's the formula. The mechanical advantage is the force ratio of the machine. So mechanical advantage is equal to force out divided by force in. Force is measured in newtons. The more a machine multiplies the force, the greater the mechanical advantage of the machine. A pulley system consists of one or more combinations of wheels and ropes, which can be fixed in place or movable. Pulleys help you lift large loads. To calculate the mechanical advantage of a pulley, count the number of ropes or cables supporting the load. So here we have 1, 2, so it has a mechanical advantage of 2 because the force is going up. So 1, 2. Here, the force is going up, but you're pulling down, so it has a mechanical advantage of 1. A single movable pulley has a mechanical advantage of 2. A fixed movable pulley or a fixed single pulley has a mechanical advantage of 1. This has a mechanical advantage of 4. 1, 2, 3, 4. This has a mechanical advantage of 3. 1, 2, 3. A block and tackle was probably invented by Archimedes. A block is a set of pulleys mounted on a single axle. When a rope or cable is run through the block or a series of blocks, the whole assembly is called a tackle. It is usually a compound machine. The most common arrangement for a block and tackle is to have a fixed block and another block that is movable, attached to the load. The mechanical advantage is equal to the number of supporting ropes. So here we have a block and tackle. We have 1, 2 supporting ropes, so it has a mechanical advantage of 2. Although used in many situations, they are common on boats and loading docks where the task of moving heavy objects must be performed manually. So here's a real-life example of a block and tackle. Mechanical advantage less than 1. In the case of machines where the mechanical advantage is greater than 1, the machine is multiplying the input force to create a larger output force. If a machine has a mechanical advantage that is less than 1, it is used for a task that doesn't require a large force output. A bicycle is a machine where a mechanical advantage of less than 1. Even though it has a mechanical advantage of less than 1, the output force causes the bicycle to move faster than the rider would walk, so it is a very useful machine. Comparing real-world mechanical advantage with speed ratio. When people calculate mechanical advantage and speed ratio, they may find that they are the same. In real situations, however, when they are calculated, they can be very different. This is because of friction. Friction is the difference between the calculated value and the real or actual value of the mechanical advantage. Friction is a force that opposes motion. Friction is caused by the roughness of materials. Because friction is a force in any device, additional force must be applied to overcome the force of friction. The mechanical advantage of the device will be less because of this added force that must be overcome. The speed ratio will not be affected. In fact, the speed ratio represents the ideal mechanical advantage of a machine, as if friction doesn't exist. Friction in a system also causes heat, which can cause additional concerns.